Okay, welcome back to the class. So today we'll talk about the quotients of polynomial function. Basically, is what we call the rational function. The easy way to understand a rational function is basically two polynomial functions. They are dividing by each other, which is called rational function. And the key concept for a rational function is you need to remember the denominator, which is the q of x, cannot be 0. And this is the way how you're gonna find the domain for a rational function. Very important. The denominator cannot be 0. Okay. So in this chapter, we'll briefly talk about what is oblique asymptote, which we mentioned before a little bit, but we didn't go too deep into that. I will teach you how to find the oblique asymptote. But this chapter, I would say the most important things is this table. You have to memorize this table so that you can do all the following chapters. Okay? Let's see. Let's do one by one. The first one, as you can see, is two polynomial functions divided by each other. The numerator, the degree of the numerator is bigger than the degree of the denominator. But this one, x squared minus 4, you can write that as x plus 4 times x plus 2 times x minus 2. And the numerator x minus 2 can cancel out with the denominator x minus 2. So the final answer for this one is x plus 2, which is a linear function. It's a straight line. But the very important thing is, from the beginning, you know the denominator cannot be 0, so x cannot be 2. So that's the reason here is a whole here. Okay? The second one, two polynomial functions dividing by each other, but the degree are the same, right? Because their degree is the same, you can easily find what is their vertical asymptote and horizontal asymptote. So the vertical asymptote is x should equals to a number that make the denominator equals to 0. So x equals to 2 is the vertical asymptote. For the horizontal asymptote, how do you find that? If they give you this form, instead of like the traditional standard transformed form, because I said the most important thing is to find the c, right? But this one, they didn't give you that form. So what did you do is, you find the coefficients for the highest degree in the denominator, which is 1, and the coefficient for the highest degree for the x in the denominator, which is also 1. 1 divided by 1 is 1. So the horizontal asymptote is y equals to 1. Okay? So for example, let me give you another example. So this one, you see the degree of them is exactly the same. The highest degree is 1. The highest degree here is also 1. So let's see. The vertical asymptote is x equals to 3 because you need to make this one equals to 0. How about the horizontal asymptote? The horizontal asymptote here is you use 4 divided by 1. So it's 1. Then the graph is basically 4, 3. The graph should look like this. Okay? Let's go back to see another one. Okay, the third one is still pretty much the same, right? The degree here and here, they are the same. So you use the one we did before. Now let's do another one. Let's see. The degree here is 2, but the degree here is x. But instead of, unlike the first one degree is 2, here is 1. This one is higher. But this one you can cancel out the denominator, right? But for this one, you can't do that. So in this case, you will have an oblique asymptote. So how to find this oblique asymptote is the keys. So how to find that is you use the long division. How to do that is long division. So here is x squared, here is x squared minus 2x. Then you will get 2x plus 2, right? Then here is x, here is 2x, use 2. So it's 2x minus 4. Remainder is 6. So you don't need to worry about the remainder. X plus 2 is the oblique asymptote. Okay? That's the way how you find it. You don't need to worry about the remainder. You just do here, do the long division. And what appears here is the oblique asymptote. Okay? Yes, that's all for today's class. Make sure you understand this table, which is super, super important.